I wonder if that webcam will be any good. Okay, it looks like it's working now. All right, so we are going to be talking about Chapter 4, which is scatterplots and correlation. Okay, so these are two topics that go together. You should never do correlation without doing a scatterplot. Okay, so let's talk a little bit about a scatterplot. Scatterplot is a visual representation to show the relationship between two variables. Okay? And so, you're going to look for striking deviations, also known as outliers. You guys are all good at finding outliers now, right?
Sure.
B, is it a strong relationship? Which means, are the dots close together? And C, is it positive or negative? Okay, so let's do a quick experiment. We'll do this for 15 seconds again. I know I always ask you guys to do your heartbeat, but it's fun to do. So find your heartbeat. Where did I go on that clock? And I'll tell you when to start. Just a few seconds. Go. All right, stop. Okay, so here's what I would like to do. I'm going to share my screen here. Let me open up Excel first. And what we want to do is we want to see if there is a relationship between your heart rate in 15 seconds and your shoe size. Before we answer that question, oh my gosh, this so drives me crazy. Oh my gosh. Who's got the old school phone? Oh my gosh, I hate it. They must have updated the computer, so I apologize for this taking so long, but it worked.
Tilt that forward.
Well, I can't because I don't have anything to put the camera on. So.
Do it right here and watch his live stream while he's doing it.
Oh, there you
Well,
go.
then it's backwards. I feel like this technological problems keeps preventing us from learning what we're supposed to learn.
It always looks good when you watch it after, though, right? So you can see the board. All right, so, all right, let's go here. Philip, can you tell me your heart rate and your shoe size? What's your heart rate? You just forgot already? You just did it.
I put it here. I don't remember it.
You don't remember? Okay, well, we'll skip that. What's your shoe size?
9.5.
9.5. Figure it out again. Measure yourself for 15 seconds, okay? 20 and 10.
23, 9.5.
Oops.
17 and 8.
Sandra? Jordan?
13 and 10.5.
Boy, are you asleep?
13?
Yeah, I was younger breathing. Slow down.
Yeah. Okay.
24 and 12.
10. 19,
James?
12.
20 and 12. All right. That
That's
is
17.
17.
Tried it.
Good job.
I tried it.
All right. Now, let me ask you a question. If he had forgotten his heart rate, could we include his data in the, we shouldn't. Okay? All right, so now the first thing we're going to do is we're going to see if there's any sort of a relationship. So we're going to highlight all of our data. We're going to say insert. We're going to go to the ones with all the dots here, Scatterplot, and we're just going to pick the first one here. And my title's all messed up, right? So we should add axis titles here. What goes down here? It's kind of hard to tell, right? What's down here?
Heart rate.
That's the heart rate.
Heart rate for 15 seconds.
And this is shoe size. And my title, Math 1040 class. And maybe we should say heart rate, oops, over 15 seconds. Okay? Because somebody might say, "Golly, y'all are dead if that's for a minute," right?
Is there a setting in Excel, like, when I was doing my test, I tried to label axes and it did say label axis, but it was not able to activate. Like, it just was light. And every time I had done it in homework, I could just label axis and label it, but on the test, when I tried to click on label axis, you know how it shows the name of the icon, but you can't activate it, it's a lighter print? Is there something different in Excel that I need to turn on in order to make that work?
Did you clicked on the plus sign?
Yes, sir.
And so if
And
you
then
clicked on
label
that, then you just
axis
type
came
on,
up.
type over the top of whatever that was there.
Yeah, I tried all of those things because they're pretty elementary, but I didn't know if there's a setting in Excel that you
Should
need.
be, should come on. Anybody else have that problem?
Probably just me.
Okay, sure.
My question is how legit is this data considering we're not, as we're comparing men's and women's shoe sizes together?
very
And
good.
like, should we move it all to one somehow, like all men's or all female shoe sizes or what?
If we were really good statisticians, we probably would take that into
Okay, so
account.
like
But
this
we're
is
just
a-
illustrating a point here.
If we were doing like most studies, we just exclude women and just do the men.
We would do the men and the women separately, but we've only got, how many people here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people here. So we're gonna lump them all
Well,
together.
I know, but I was figuring, could we at least make them all like one standard form? So like, if the guys, we just like.
We probably should separate the men from the women because they do have different shoe sizes, but yeah, for sake of this experiment, I'm not gonna worry about that.
We're good. I just.
Okay, so what do you think? So let me back up here. Let me stop sharing for a second here. So you can see what we did with that. Now, actually, maybe I'll share. You know what? I changed my mind. We're going to share. Now, I know some people think that Wikipedia is a horrible thing, but I actually like it for math. So they have a thing called correlation. Okay. Now, this is a great little graph here. Now, this kind of shows you the correlation coefficient, which I haven't showed you how to calculate yet, but I will. So you can see this is a positive one. You can see over here, this is a negative one. You can see in this middle line, all of these have either positive one or negative one. So the positive or the negative just refers to not the slope, but the direction. So if you're going from low to high, low to high, low to high, that's going to be a positive slope. If you're going from high to low, high to low, high to low, that's a negative slope. And so you can see the correlation coefficient. Maybe I'll write this on the board, even though you can't see it, but we'll into this. So R is the letter we use for the correlation coefficient. And it is always a number between -1 and +1, unless you do the math wrong, okay? If you get a number greater than -1 or +1, and then, or outside of +1 to -1, then you did something wrong. So 0 can imply no correlation if backed up by a scatter plot. Okay? So you can see, let me throw something else out here. So for a general rule, if you have, and I'm going to use absolute value here, if your R is, absolute value of R is greater than 0.7, we're going to call that strong correlation. If your R is between 0.3 to 0.7, we're going to call that moderate. You write that way. 0.3 to 0.7. And if your R is less than 0.3, we're going to call that weak. Okay? Now, one of the problems is students often, when they're looking, they will figure out their correlation coefficient without looking at the scatter plot, and that's a mistake. Okay? Now, as we look at this graphs here, you can see we've got +1, which is like perfect correlation. If you were to correlate your heart rate with your heart rate, it would be a perfect line, because it's just perfect. Okay? Generally, so this would be 0.8 correlation. You can see the dots are still pretty close together. 0.4, we call this a moderate correlation. 0, we would refer to as no correlation. And then we have the same thing in the negative direction. Okay? So 0.8 and -0.8 are equally strongly correlated. Just one's positive and one's negative. Does that make sense? Okay? And it doesn't really refer to slope, other than you're getting a direction. Okay? Now, on this bottom row here, we have a bunch of data, and if you were to plug in your correlation coefficient, and I should mention here, the correlation coefficient measures only linear. You notice linear has the word line in it, correlation. Okay? So whenever we're measuring the correlation coefficient, we are always assuming that it should be a straight line. Okay? Now in the bottom row here, you can see that we have a lot of stuff that are not straight lines. Okay? So if you only looked at your correlation coefficient, you would incorrectly conclude that there was no correlation going on, when in fact there is some sort of a nonlinear correlation. This looks like a W kind of. These all look like fake data, but you can see here, this one here, this looks like kind of like a parabola. That would actually imply a nonlinear correlation. Okay? So linear correlation in this case would be a bad idea. This looks like it's two different populations. We've got this 0 here, I don't know what that is. This to me looks like I've got 4 different populations going on. Okay, and so whenever you're figuring out your correlation coefficient, the first thing you should do is draw a scatter plot to see if any of these things, especially on the bottom row, or that's not all, but let me show you. I'm going to stop sharing here and show you the board. Okay. You could also see something that looks like this. Okay. A lot of times we refer to that as the banana. we refer to this as the hot dog. And we refer to this as the hamburger. I think somebody was hungry when they decided making these.
Yeah.
Okay, so we're hoping for the kind of the hot dog. We want it to be roughly a straight line. If you see a curve like this, you can still calculate the correlation coefficient, and it might be quite strong, but it would be an incorrect use of the correlation coefficient because clearly there's a curve going on here. Okay, down here we've got our hamburger. This would imply no correlation here, no correlation. Okay, now if you watched my video yesterday, which nobody did, we talked about multicollinearity and collinearity problems. That's actually beyond the scope of this class, but it was a good conversation and you should check it out if you missed it. Check it out this weekend. Okay? All right, so the idea, and I don't care if it's in a positive direction or it could be in a negative direction. Okay, we're looking for something that's roughly a straight line. Okay? So now that you know all this, let's go back to our graph here where we tried to see if there was a correlation going on. Okay? So what do you think as we look at our data here? Would you call that strong, moderate, weak, no, or nonlinear correlation?
To me, it's a non-linear.
Nonlinear?
Yes.
You think it looks like a curve?
It looks like everything is, I don't know, might be a curve or whatever, because some line come this way and some of them, and one of them come this way.
Okay. What do you guys think? That's what Philip thinks. What do you think, Sandra?
It looks like,
You think weak? Okay. Christian, what do you think? We'll get one more answer, then we're going to figure this out.
Those kind of look like a line point.
So you're saying, would you say, if we were to call this line, would it be positively or negatively correlated?
positive.
Probably positive. Okay, so let me give you the equation, and this is going to be on your test. Okay, I'll give you the equation, but we're going to go ahead, we're going to assume that this is good enough to be a line, and I'm going to give you the equation. I'm going to have to erase something here, okay?
So you provide the equation, we just don't have.
I will provide you the equation. You guys are going to have to either memorize the steps or I want you to calculate the correlation coefficient manually, okay? So R equals the sum of xi minus x bar over s sub x times yi minus y bar over s sub y, all divided by n minus 1. Okay, so that is what we call the correlation coefficient. Okay? Now, what do you think S stands for in this equation? S sub x. What do you think S stands for?
Sample.
Sample? Not exactly. It does refer to a sample, though.
Shape,
What'd you say?
shape,
Shep?
shape of the air.
No.
Size.
What'd you say?
Size.
Size? In the parentheses, does this look like anything you've seen before?
It looks like a variance.
Not the variance, but the standard deviation.
Well, a portion of the standard.
Yeah, this looks like it's the z-score, right? Basically, only I'm using an S instead of a sigma, and that's exactly what it is, okay? So, for those of you who like to memorize steps, okay, I'm going to give you some steps to follow when you're doing this. Now, here's what I would recommend on your homework, okay? They're probably going to give you some data, and you should practice doing this in Excel, even though the questions don't ask you to do this, okay? Now, number one, I want you to find the mean of your x and your y variables. So your x bar and your y bar, right? I want you to find the standard deviation of the x and the y as well. I want you to find the z-scores for your x and your y. Number 4, I want you to multiply your z-scores together. Okay? So let's just make sure. I'm going to give you this equation, and theoretically from the equation you should be able to do these steps. Okay? You're going to find your x bar, your y bar. You're going to find your s of x, your s of y.
S of x is what again? Can you remind
S of
me?
x is your standard deviation for your x, your standard deviation for your y. Okay?
How come you don't use the standard deviation sign for that?
Why do I not use the
Is it the
sigma
sample?
sign?
Is it the sample?
Because this is from a sample
Instead of from
instead of from a population. Okay? And that's why I use x bar instead of mu, because x bar represents a sample, mu represents a population. Okay? All right, so I found my means, I found my standard deviations, I find my z-score for the x, I find my z-score for the y, I multiply them together. What does this mean? Add them up, sum. Find the sum of the z products. And then step number 6, which barely fits on there, is divide by n minus 1. Okay? That barely fits on there. Okay? All right, so we're going to do that with our real data that we collected in class just now. We're trying to see if there is a strong, moderate, weak, or no correlation. Okay? So let's do it here. Okay? I'm going to slide this over. Now, what's my first step? Find the mean. Do you remember how to find the mean quickly and easily?
Equals average.
Oh, nobody wants to say it. Equals average, because now you've got to wash out your mouth, okay? So the average heart rate was 18.4. The mean shoe size is 9.75. I think that's what we got before. I don't think that changed. Okay? Do you remember how to find the standard deviation quickly and easily? I won't make you do this by hand again since we put it on the last test. Equals ST dub, which one? Dot S. Okay, this one has to be dot S. Okay. So the heart rate standard deviation is about 3.5 beats.
What is standard deviation? What is the ST?
STDEV. Okay. All right, so I found my mean and my standard deviation. Now I need to find my z-score for the x and my z-score for the y. Okay, so we are assuming, I guess, by the way, the heart rate is the x variable and the shoe size is the y variable. Now, one other thing that I should mention really quickly, this book makes a bigger deal about it than I do, but when you are doing your scatter plot, okay, usually you put the independent or the x variable here, and you put the dependent or the y variable here. Another word for that is the explanatory variable and the response variable. Okay. Now the question is, let me ask you this question. Does your shoe size cause your heart rate to be bigger or does your heart rate cause your shoe size to be bigger?
I would say that it's not correlated.
It's kind of hard to tell, okay? So here's the deal. With correlation coefficient, honestly, it doesn't really matter. The way I did it here is I'm putting the heart rate here, and I'm putting the shoe size here. But if I were to do it again with the shoe size here and the heart rate here, it might look like this.
Can't see that on the screen.
Oh, you can't see that one on the board? Thanks for warning me. Can see that. Okay, so so this is the way I've drawn it, and actually that's not, but if I were to do it again with the shoe size here and the heart rate here, it might look like this. It might have a different slope, but the correlation coefficient will not care which one's which, okay?
Is that always the case?
No, it's not always the case, okay? But in this case, does it really matter whether your heart rate's on the x-axis or the y-axis? Does one explain the other? Okay, let me give you another example. If we were going to do a scatter plot where this so we wanted to do your time spent exercising versus your weight. Okay? Would the time spent exercising explain your weight, or would your weight explain the time you spent exercising? What do you think? Time spent exercising would probably explain your weight. You would probably, and so time spent exercising should be on the x-axis, and your weight should be on the y-axis, okay? People who spend more time exercising generally weigh less, correct? So this would be a good example of what we would call a negative correlation, okay? So if it's a clear case like that, yes, time spent exercising should be on your x-axis and your weight should be on the y-axis. Does that make sense? Okay. Time on the x, yes. But in this case, it's kind of hard to say, is there really a relationship between your heart rate and your shoe size? It doesn't really make sense, right? Okay. We said before we thought that there was either no relationship or a very weak relationship, right? Okay. So let's keep going and see what happens when we do our thing here. Okay. All right, so we found our mean, we found our standard deviation. Cade, what is the next step?
Yeah, the z-scores.
We need to find our z-scores. Can you help me do that? So here's your equation here. What does x sub I represent?
X represents, I don't remember right now.
Did you look at your notes from yesterday? That should tell you. Remember the z-score I gave you yesterday? And I put it into words?
Data over mean, or data.
A data, right?
Yeah.
Okay, so what's my data in this case?
Heart rate,
So the 17 in this case.
yes.
And then we're going to subtract. What's x bar? Which mean?
The mean of heart rate,
Which is
like,
18.4. And then what do I do next?
you need to put the F4 on.
F4. Way to go, dude. I didn't think you'd remember that. That's awesome. Okay.
Oh, yeah.
Because we want that A14 not to change, right? The first one we want to change, the second one we want not to change. Okay, well done.
Not it for that. We need to divide it.
What are we dividing it by?
All the
Standard deviation.
Standard deviation of x, which is 3.47. Is there anything else I need to do? Yeah, what? No, I don't know the square root that. What'd you say? The dollar signs, F4, okay? Is there anything else I need to do? Okay, there's actually a mistake, but we're gonna let this mistake slide for a minute, okay? Watch what happens when I copy this down. Oh, actually, it didn't do what I thought it would do. There is still a mistake, okay? Do you notice my numbers are 11, 14, 17? They should be a lot closer to 1. Okay, so that's your clue.
But there's no, that we made a mistake in the formula?
There's a clue that you made a mistake in your formula because these should be close to zeros and ones. Because remember, the R is always between 0 and 1. I didn't use parentheses. I used all the correct numbers, but I did not use parentheses, okay? So on this first one, I need to make sure that the numerator is in parentheses. Okay? That's the only difference, but you're going to see that 11 now becomes negative 0.40. Okay? Do you see what a big difference those parentheses make? Okay? Now, when I copy this down, you can see they're all between zeros and ones now. Does that make sense? What'd you say? Do a little bit bigger. It's okay. Okay? Now, James, can you help me do the same thing on the y-score? The z-score for the y variable.
So for that formula, are you using the one that has the standard deviation over the square root of m?
This one right here. Are you asking about my standard deviation? I'm not making you figure it out manually, but remember, since S represents your sample standard deviation, am I dividing that by n or n minus 1? N minus 1. Okay?
Yeah, because sample is always in minus.
Sample is always n minus 1. Population's n. So does that answer your question? Okay. So James, can you help me do this?
So we're doing oops.
Equals.
So y 9.75.
So the y is the 9.5. We're going to subtract y bar. What's the y bar? That would be 9.75. Divide by which is 1.56. Is that correct? Got to put the dollar signs where? B15. Parentheses where? The numerator, right? B3 and B14. Am I right now? What'd you say? Dollar signs on the B14 too. We want that mean and the standard deviation not to change. Okay? Does that make sense? And if I do it right, it should be numbers close to 0 and 1. That looks right so far. If I copy it down, that looks right. Okay, Aaron, what's the next step?
Divide by
Nope.
multiply. Wait, what's the I'll see it. Multiply z scores together.
Yeah, we need to multiply these z-scores together, right? Okay. So multiply. And how do I do that? What am I equals? What number am I multiplying?
The two numbers. Did you click it?
This one here times the next one. Okay. Oh, do I need to F4 those? No, that's correct. Okay. Copy that down. The next step is what, Christian? Find the sum. How do I do that? Auto sum, very good. I hit my little E sigma thing. Okay. Got a sum of 3.58. Alex, what's the next step? Divide by n minus 1. Now my question to you, is my n 10 or 20? What do you guys think? What? It's 10. Okay, n is your number of pairs. Is your n 10 or 20? And it's 10 because I've only got 10 students, right? So I've measured everybody twice. It didn't turn you into 20 students. You're still just 10 students, right? So n is your number of pairs. So I'm going to divide by, in this case, what? Divide by 9. Oops. Divided by 9. Okay? Now, if I did it correctly, I should get a number between 0 and 1, right? 0.398. So we would call that moderate correlation, okay?
Why we divided it into 9? We have 10.
Formula.
Oh, okay. Yeah.
That's the formula, divided by n minus 1. What'd you say, Aaron?
I'll figure it out. I'll just tell what I'll say.
Okay. Now, do you think that there's a way that Excel will figure this out without you doing all this hard work? Of course. And how many points will you get for doing it that way?
0.
0. But would you like to show me anyway? Would you like me to show you anyway?
No.
So you can check your answers on your question?
Yeah, so would Excel come up with the same answer we would, like there's not a difference?
Excel will come up with the exact same answer.
This is called the correlation.
Correlation coefficient. Okay? Now this one's slightly tricky, but not too bad. Okay? If you were going to come up with a command for the correlation coefficient, what would you call it? Correlation, right? So C-O-R-R. Oh, how about coral? Okay? Coral for the correlation coefficient. Okay? Now it's asking for array 1. Array 1 basically means your data. So that's your X data. Okay? So I'm going to highlight my X data in this case. Then I'm going to press a comma, and it's going to ask for data 2 or array 2. And I'm going to highlight my second data set. I'm going to close the parentheses. And look at that. You are now as smart as a computer. Doesn't that make you feel smart, Philip?
You missed it.
No?
Oh, that's why.
I still have a problem figuring out how to put the.
Okay, so you need to practice. This is going to be on the quiz tomorrow. Okay?
This is gonna be,
I'm definitely going to give you a test question that says, here's some data. I want you to show me how to find the correlation coefficient by hand, and you need to be able to go through these 6 steps. Okay? Sandra's like, by hand? Are you kidding me? No, I'm not kidding. All right. So,
can I ask a simplistic question?
sure.
Can you just show me in this again, where you divided x1 minus the mean by the standard deviation? Where on this spreadsheet did you do that step?
Did I do what?
Well, the numerator on top is xi minus the mean, and then it's over sx.
Yeah.
So that's the division.
That's your z-score right here.
Thank you.
I did that all in one step.
Okay, thank you.
Okay? All right, do you want to do one more?
Why not?
Should I have you guys do it?
For extra credit, yes.
No.
it's
Well, Aaron's already done it once, so I'm going to pick somebody else. But here's what I'm going to do. I'm going to make up some fake data here. This is going to be your weight and miles per gallon.
What?
10, 12, 14, 16,
Oh, like the weight of a vehicle.
18. These are in thousands of pounds.
Okay, so like.
This is 20, 25, 30, 25, 20. Okay? So here's what I'm going to do. I'm going to lay down while you do this so that my back doesn't hurt. But I'm going to pick who would like to, besides Aaron, come demonstrate how to find the correlation coefficient by hand.
I'll go do it if you help me, and I might.
Yeah, I'll help you. I'll just lay down and do it. Okay, do you want to do it?
There's
I'll
nothing
try.
wrong with crying in class.
I think I would just lay down and walk. Yesterday was
I'm gonna cry, so.
Don't cry.
Okay. So first down here, we're gonna find the mean of this data.
That's actually the second step.
Find the sum.
Oh, sort the data?
That will screw it up, actually. If you sort your data
Oh,
out,
because you need it to be matching with
Once you
each.
make a scatter plot.
There we go.
Oh.
Scatterplot. Thank you, Jordan. That's the
Okay, I
first
can do
step.
that.
Okay.
Team effort, let's do this.
Scatterplot. Oh, wait a second.
Did I do that wrong?
Oh, you know what? You did it right, but that 30 should be a 20. Change that 30 to a 20 on the bottom.
Here?
Yeah, I wrote the data.
Oh.
Okay. Now, what do you think of your scatter plot?
Hold on, I'm gonna redo it.
Okay, and actually, she should label it. Yeah, well, this is good, so we can practice. What is that?
What is it? Say something and I'll type it.
Start typing.
The way.
There. And this is miles per gallon. And then here we're doing, what are we gonna call this? Vehicles?
Yeah, vehicle, something like that. Okay, so did you figure out what you did wrong on your test or whatever?
No, because I did those steps, but I don't wanna talk about it.
Okay. All right, so now, what do you think? Is linear correlation a good idea on this data?
Well, this is like a banana, right? Would this
The
be?
negative and positive at
Yeah,
the
you
same
could call
time.
this a banana.
Or round.
So is
Oh.
a straight line a good choice for this?
No.
No, it's not, okay? Technically, we should not find our correlation coefficient because we did our scatter plot and we said this was not a good fit. But we're gonna do it anyway, just for practice. Okay?
Okay.
All right, now,
So-
the first step of your correlation coefficient is?
That terrible thing that you're supposed to not say.
Yeah, that terrible thing you're not supposed to say, Taylor.
Equals, the A word.
Finding the mean.
I'll say it.
I don't want to tell this class just for saying that word.
Okay?
I'll say it.
Just press enter.
I always do that and then it.
You can actually copy that and paste it if you want. At 14.
Why would I do that?
We can save time. Press Control C,
Oh, gosh.
move over one, press Control V. See, that saves time.
What the fudge?
Yeah, you know that.
I thought it would just repeat the same calculation. Okay, so that's your,
That's
these
your
are your
mean, right?
mean. So the next one, find the standard deviation of X and Y.
Correct.
So,
Equals STD.
and I do this because it's a sample.
Double click it.
Oh.
When you select it, you have to double click it.
See on the MacBook.
Nobody likes
Okay.
a MacBook.
I can't afford one.
Okay.
So that's the standard deviation.
deviation.
Maybe over here I should actually put that these are the means. That's nicer, eh?
Okay.
Okay.
Oh, they're correct. Against both these.
So find the z-scores for x and y. So that's what I have to do up here. Okay, friends.
What?
Help her out.
Equal.
You're doing good.
Equals. So go up to the top row where you are.
Okay,
Oh.
Where the 10 and 20 are.
Equal.
So I do due to the z-score, it's the number of the data point minus the mean divided by the 3.16.
Click on the 10,
Don't forget the dollar signs.
minus.
Okay.
Oh,
Dollar
wait,
sign.
we got it.
Okay,
no,
minus,
parentheses. Let's
oh,
do parentheses first.
parentheses. Minus the mean.
F4.
What's that for? Oh, yeah, because the dollar signs.
Yeah.
And I do this divided by the standard
Well, you
deviation.
subtracted the wrong thing.
Oh, I did because I subtracted the standard deviation and I should have subtracted.
You subtracted the standard deviation, not the mean.
Okay, I'm sorry. Okay.
Oh, yeah.
Parentheses.
Whoa, how did we get 0 on one of them?
And I do F4 divided by the standard deviation. F4 again?
Yep.
Ooh, is that right?
Okay.
Maybe.
Looks good so far.
And then I would just do this, eh? Like that.
Okay.
Okay, so now I have to do, oh, the same thing for the y-score. I didn't put x at the last one, but I'll. Equals this. Oh, can I just copy it from, can
No,
I?
you can't.
Okay.
You can copy it, but it won't give you the right answer.
Why? Okay, I'm not gonna ask. Y1 minus the mean, make it F4 because of the dollars, divided by the standard deviation. Okay. Oops.
Okay, what did she do wrong that time?
Je ne sais pas.
She was very close, but there was one thing that she forgot to do.
Pardon?
She forgot to
Ooh.
put the second one.
No.
Okay? All
Okay.
right.
Multiply the z-scores.
Oh, that is.
Which
I
one?
like how she's labeling those. That's so helpful if you want partial credit.
Yeah, I got a question. What happens when the sum equals 0?
Yeah.
Well, that's a good question.
This. And then would I do an F4 and can I carry it
You
down?
do an F4 on this?
No? And can I carry it
Well,
down?
that means you're on the same.
Yeah, I'm like,
Cause I'm like, dude, I can't go to the next step. That's looking to be 0. But I mean, if you look at the scatter plot, it looks the exact same anyways. It looks like a mirror image of a parabola.
right.
Did I do that right?
Yeah, so far. What's the next step?
Sum. Just go down to the bottom. I think it'd be easier.
Oh, down here.
Yeah, so it can just auto
Go
sum
right
up
under
over
it.
or to your right. Or, there we go. Then just go to the auto sum. So.
That works too.
Yeah.
But you can do it that way, that's fine.
Oh, yeah, I can do that little guy up here. Huh?
Yeah.
Whatever
What they call?
Don't have to highlight it. It's just go underneath it and press it. That's it, sure.
Okay, so you got a sum of 0.
Zero.
Is that,
Is
that's,
0 a valid answer? She's
Yeah.
not done yet.
Technically, yes.
But is 0 a valid answer?
Yes.
Yes. What does 0 often imply?
No correlation.
No correlation. But in this case, is no correlation the correct answer?
No.
No, it is a. It is a nonlinear correlation, right?
No.
Technically, she's supposed to divide that by what?
n minus 1, which would be,
N minus, yeah, n is 5, so n minus 1 would be 4. So she takes that and divides it by 4, she'll be done. She still gets 0, so she labels it correlation coefficient.
these ones down here are correlation coefficient? Is that right?
Yep. And then, yeah, so there you go. All right. So,
So
that
was this
well done.
performed accurately? It's just that there's no correlation because the data doesn't
Well,
correlate?
So remember, the correlation coefficient assumes it's a straight line, and this is not a straight line. So that's why you get a 0.
Okay, thank you.
And that was why I created that data set to do that.
Didn't even cry.
I did.
Okay. All right. So now,
So 0 would just be like the correlation would be.
what'd you say?
Negative or something like that.
Say it again.
0 would just be the correlation.
So if you calculate the correlation coefficient, it's 0. Does that mean there's no correlation? No, because the scatter plot says it's a nonlinear correlation. Okay, so the correlation coefficient should not apply in this case. That's why if I had done the correlation coefficient right off the bat, I would have said, no, I'm not going to do the correlation coefficient because it's nonlinear. Okay, now, we're not going to learn, other than do your scatter plot and say, is this a straight line or not? We're not going to learn how to do nonlinear correlations. There are nonlinear correlations out there, but we're not going to do that. Okay? Now, let me show you some cool websites now. So I've already showed you that one. Now, just as a reminder, analytic. Hopefully I typed that right. I did. Okay, so this is just a website I just want to kind of show you. So remember, a correlation coefficient measures how close the dots are together. So this would indicate a strong correlation. This would indicate not as strong of a correlation. So just to give you some ideas, I know we're using small data sets, but this would be an example. This is a correlation coefficient of 0.03. It's really rare to get a 0 unless you purposely make it that way, like I did on the last example. So would you say this would indicate no correlation? Yes. Yes, because it looks like a hamburger, right? There's no pattern going on here, no straight line, no curved lines. It's just a bunch of dots. So correlation coefficient close to 0 would indicate no correlation. Okay?
How close to 0 would you say?
How close to 0? 0.03? That's only 300ths away from 0.
I know.
Less than
Yeah, but we
0.3.
want to know, like,
Yeah, like,
Is it less than
I think it's like 0.5. Like, you know what I'm saying?
0.5 would be what?
moderate correlation?
Moderate. So let's look at some correlation coefficients. Okay, so 0.28, what would we call that? We call that, you can kind of see, it's a very wide line here, but yeah, you can call that a weak correlation. Over here, 0.48, which is close to 0.5. We call this moderate correlation.
0.72 is strong.
Okay. 0.72 would be what we would call a strong correlation. Okay. 0.89, a really strong correlation. 0.99, I'd almost wonder if you faked your data. That's too strong.
And correlation coefficients are, isn't it?
R. That's what we use. Okay. So anyway, that's kind of some visual representations of that. Now, here's a couple things I want you to be concerned about. TylerVegan.com/spurious Correlations.
Who's rather vegan?
I have no idea. Okay, but look at this, okay? So what they've done here is he's shown U.S. spending on science, space, and technology, and suicides by hanging, strangulation, and suffocation.
So the less money spent on technology, the less suicide.
Fewer suicides we'll have, right? Because doesn't math want to make you commit suicide?
Yeah. That's modern technology makes you want to commit suicide.
Okay, do you think these are related?
Heck yeah, but
How about this one? Nicolas Cage films Nicolas Cage appeared in a number of people who drowned by falling in a pool. You watch a Nicolas Cage movie, you just want to fall in the pool and die, right?
dude,
What
I'm
happens?
down, dude.
The fewer Cage films there are, the fewer deaths. We got to stop Nicolas Cage, right? Okay. You heard the phrase correlation does not mean causality. This is an example. Just because two things are correlated doesn't mean they're related. How about this one? Per capita cheese consumption and number of people who died by becoming
Well,
tangled
I'm
in
glad I
their
don't eat that
vegetables.
much cheese anymore.
If you eat cheese, you'll die in your sheets. Okay? We'll do one more. This is a fun website. Divorce rate in Maine and the per capita consumption of margarine.
Well, it's because they're not eating.
Don't eat margarine or you'll get a divorce.
That's why you eat butter.
What's that?
That's why you eat butter, not margarine. It's better.
There you go. So anyway, so
What did you say correlation is not equal causality?
correlation does not equal causality. And by the way, these are other examples of nonlinear correlations, right? These are not straight lines. Okay. Now there is another thing. Oh, I've got a lot of stuff I want to show you. We'll stop here because we're about out of time. But
So what's our quiz on tomorrow?
quiz is on chapter 4. But I've got something on Netflix that I want to show you. You don't have Netflix.
I'm a broke
Seems like
college
every
student
year.
and can't afford Netflix or Hulu or anything.
So you can just, sit over.
What?
You didn't give it to me. Here, just a minute. Let me finish this.
Well, my thing is, if I get those, then I'm gonna like not do my homework, and I'm gonna be less like I'm gonna be a bad student. Not if I'm watching Netflix. I'm the person that paid to watch an entire show. Like with Orange is the New Blackout right now. I'm glad I don't have Netflix, or else I'd be binge watching that instead of doing homework.
I'll be doing both at the same time.
I can't do both at the same time. I'm too old. I can only focus on one thing, and it's usually Netflix over homework. So when I first started college, I used to do that, and my GPA sucked. But now my GPA's been on the dean's list for the last 4 semesters, so.
Just dropping those sick rags in there, man.
Oh my gosh.
Just dropping those sick rags.
I'm only happy about it because my health is in high school. Except for this class, I'm just good with GPA. I'm just like, quit trying to be a doctor. Go work at a janitor somewhere.
Honestly, most of us are probably gonna be janitors.
Dude, I have a friend that graduated with a 3.97 GPA and now.
It hasn't sent me this thing.
At a school district. The benefits instead of like doing anything else is like job security, bro. You get good benefits.
Might as well.
Why won't this give me my code?
It's probably a song because the class is almost over, you know what I'm saying?
Yeah, like send you the previous one, it's gonna say this code is no longer valid.
Well, they won't send me anything. Oh, now I got it.
Sure.
Yeah, great.
You gotta figure out what road we're going specifically for the speed limit, because if we decide to do that, one, then we have to do the exact. I didn't hire it, just pick random roads.
Right.
Yeah, that's what we should talk.
But I'm totally down for the M&Ms. Because I'm really excited to eat that data. It's really good with the it's $5 Tuesday. I heard the new Strangers 3 was, the season 3 was really good. I heard some of that have been forceful things.
Oh no, Freakonomics isn't on here. How did that happen?
Probably filming that Stranger Things season 3 on there, so stop freaking out.
Okay, I probably better stop the video because I don't want to break any copyright things here. But so I'm going to stop the video, but I will show you here in class. How do I stop this?
All I know is you at least got 1 view on your video so far on your live stream.